everyone. Hey, my name is Mansi Kulkarni and I am a senior software engineer at Red Hat. And today I have Ritika Gupta with me. She is a software engineer at Oracle. Today we are going to talk with you how to effectively monitor and debug Windows containers on Kubernetes using tools like Prometheus and OpenTelemetry. Okay, so this is the agenda of the talk, and we are going to cover some interesting topics here, especially why Windows containers matter, and then how to set them up, how to monitor them, how to debug them. And then to keep things interesting, we are also going to do a demo, and we'll show you a Grafana dashboard. And then we will jump onto a cluster to do some debugging of Windows nodes. That will be covered by Ritika. We will also have some time for Q&A, and hopefully you'll see some questions at the end. Okay, why Windows containers? Let's see why this matters to us this much. Windows containers bring cloud-native principles to traditional Windows workloads. You may have heard about many enterprise applications which are built for Windows OSs and are built using very Windows-specific APIs. Those are mostly legacy Windows applications. If you want to take advantage of Kubernetes orchestration and run Windows applications alongside Linux workloads, we need Windows containers running on the Kubernetes clusters. Windows containers allow these applications to run in a containerized manner without needing a complete rewrite for Linux. So now that we've seen what Windows containers are, let's see if you have a Windows VM in cloud or on-premise, you can bring that up and join it as a Windows node to a Kubernetes cluster. You have a few methods of doing that. The first one is KABC, which is nothing but a cluster API provider. We also have kubeadm support, and then there is a Minikube prototype that is available if you want to bring up a cluster locally on your machine and add Windows nodes to that. And these are all managed by SIG Windows. So there is a URL that I have pointed there. You can follow that for updates. And if you have any concerns or issues that you run into while setting up, you can definitely reach out to us on Kubernetes SIG Windows Slack. Finally, these are all managed by the user. But if you are interested in doing a managed Kubernetes service, you also have an option of OpenShift, AKS, and EKS, which will take care of joining the instance to your Kubernetes cluster and also provide you support for that. Okay, so let's see where is the gap in Windows and why we are doing this talk. You may know of many solution architects who specialize in Linux containerization, right? They are helping organizations re-platform legacy Linux applications. But do we know of any architects who would do this for Windows? Maybe not. Lack of expertise is a problem in this area. Second, data for Windows on monitoring is currently scarce, which creates a gap in our ability to monitor Windows systems in a unified interface. To give you an example of this gap, in the OpenShift console that I work on, we had the query or the consoles built primarily for Linux, and we had to rename our Windows metrics to the Linux counterparts just so we could have some visualization provided to our customers. To put it in a nutshell, Windows applications have almost been an afterthought, but we don't want Windows applications to be left behind in the modernization process. Observability on Windows node isn't as seamless as Linux today. Metrics collection, process visibility, and debugging require special handling. That's where HostProcess containers come in. So let's see what they are. HostProcess containers, particularly in the context of Kubernetes, are containers that operate as normal processes on the host machine, so they have access to host network, storage, and devices. This is similar to Linux privileged containers if you have used them. And why are they important to us? Because earlier services like kubelet, kubeproxy had to be run as Windows services and had to be registered within the Windows Service Registry. So for every issue you would have to SSH onto the node and debug it. With this feature addition, you have a base image which you can use to build any service and deploy it as a daemon set pod. You would agree that the process of deploying has made this compare with Linux. For example, now we can also use the kubectl debug command, which streamlines developer and maintainer experience. So basically, with this feature, you have a coherent solution which fits within the Kubernetes ecosystem. So let's see why monitor and why this is important. While there are numerous reasons to monitor, according to me, the top 3 are make informed decisions, optimize performance, and strategically manage cost for infrastructure workflow. So I feel like these are the reasons that every organization should put effort into monitoring. Okay, so let's go through a high-level architecture diagram of Prometheus. This is from the official Prometheus website, and see how all of the pieces connect. Here we have a node which sits at the bottom of this diagram, and on top of that we have a Prometheus server running, which will query the node for all of the metrics. These metrics would be a little different for Windows and Linux. For Windows, we have the node metrics coming from kubelet, and the container metrics coming from containerd, which would be cAdvisor in case of Linux. So you would store all of these metrics in a local time series database, and you would query them using PromQL query language. These are available over HTTP, and you could visualize them in a Prometheus web UI or Grafana. You can also add thresholds and send alerts to whatever app that your organization prefers, like PagerDuty, email, or Slack. And finally, since we have metrics coming from a lot of different sources, we need a format that is understandable to Prometheus. So we have some agents which are called as exporters, which do this for us. For Linux, you may have heard about Node Exporter. For Windows, we have Windows Exporter. This is an exporter that is added by the Prometheus community. It's not officially maintained by Prometheus itself, but it has a lot of useful collectors. As you can see, there are some collectors that are enabled by default, like CPU, memory, network, mostly all of which we could need. But there are also some other custom ones that you can add, and some interesting ones like container and processes. You would basically configure them as command line arguments when you're setting up the Windows Exporter service as a daemon set pod. And yeah, we come to the end of the monitoring thing, but this is something that the OpenTelemetry integration that we have added in this talk, because we feel that it completes the picture that we are trying to draw. So I'm going to give it to Ritika because she is an expert in OpenTelemetry.
Thank you, Mansi. Appreciate you walking us through why monitoring is important and what Windows Exporter does. Building on that, it only makes sense to kind of build that obvious extension out for OpenTelemetry as well to complete the end-to-end observability pipeline for Windows containers. Why Otel? Well, Otel's the vendor-neutral industry standard that's used for instrumentation, collecting and exporting telemetry data, all of that, right? Let's take a quick look at how we leverage Otel specifically for Windows containers instrumentation. So building on the Windows exporter that's deployed on each Windows node, we basically have a metrics endpoint being exposed at 9182. We deploy an OpenTelemetry operator on OpenShift. All of this has been tested and worked on at OpenShift. We use the Otel Collector scrapes this metric endpoint, and the Otel Collector can be configured to export these metrics to a data visualization tool like Grafana, Thanos, whatever we end up using in a production system. So on the right-hand side, left-hand side of this slide, you're going to see a snippet which is going to talk about the pipeline and the receivers and the exporters over there. And we specifically have that tweaked to only monitor Windows nodes and a particular port that gets exposed. So that kind of like wraps up the whole end-to-end experience for Windows container observability. Now that we understand how all of that works, let's dive a little deeper into understanding Windows nodes and why it gets so tricky to debug Windows nodes, and how can we do that using HostProcess containers and kubectl debug command. Well, a picture on there is from SIG Windows, probably 2 years old, but it basically shows you all the core components running on a Windows node. and how the Windows node helps enable container orchestration. What you're going to see over there is the core Windows service that runs on the host Windows kernel, which interacts with the HCS and HNS, that's the host compute system and the host network system. The host compute system manages Windows container lifecycle and isolation, and the host network system governs container networking, IP allocation, container routes, so on and so forth. Now, on top of that, you have the CNI and the HCS shim, which interact with these host services to enable container management, configuration creation, container resource creation, all of that. In the example over there, you're going to see containerd, but it could be a container runtime, which is used for container execution and image management. Now, finally, tying this Windows node all together is the kubelet, which helps register your Windows node with the control plane of the Kubernetes cluster. Now that we understand what the core components on a host node look like, let's move on to the right side of the image, where you have two types of Windows containers that are supported. The first one, usually everyone runs that for their Windows application, is the process-isolated container. The process-isolated container is a lightweight, sandboxed environment with its own user space, but it shares the host kernel. On the other hand, you have the host process containers, which have the same privileges like a host, as Mansi delved into that. Hence, it's an extremely powerful tool, because you can use it as a Kubernetes pod, and you could use it to debug your node components, because it shares the same host namespace, the host network, host peripherals, host devices, all of that, right? It's almost like privileged Linux containers, right? Now that we understand that, let's look at how the kubectl debug command would work for Windows containers, and what are the key things to keep in mind over there. So the kubectl debug commands, here are a few things particularly to look at that command. The first one is we're using the host process base container image. Why that image? Because it's an extremely lightweight image. It's about 7 to 8 KB. Anyone who's worked with Windows images knows that they go into quite a few megabytes. So that's why the base image there, because it's going to enable you to have a fast startup time. The second thing to note there is the custom YAML, where we set up in Windows options and the security context that it's a host process container, and the other call out over there is the username and the user group. In this example, it says NT system admin. Technically, it could be a custom user-defined user group that you use specifically for debugging, especially for this example. Another thing to note over here, even though Windows containers support Windows node debugging, Windows containers do not support Windows pod debugging due to limitations around ephemeral containers. Well, moving on, I have listed over there a few best practices and troubleshooting guides on how do you debug the host compute system, the host network system. They're all pretty well maintained by SigWindows group. The third point on there is a custom host process base image with debugging tools already packaged into it. A shout out to James Stuttervant over here for sharing it with the community. The last thing there is our YAMLs and the setup files that we've used within our demo that we're going to show you next. So if anyone's interested in replicating it or trying it out by themselves, feel free to head to that GitHub link and give it a shot. All right, I'm going to start the demo here. You'd probably have to go and click play. Over there. Maybe the URL. Oh, wait a second. I think I know how to do that. OK. There you go.
OK, so here I have a cluster which is set up, and this is an OpenShift cluster which is brought up on Azure. So here we see a list of nodes. The last two you see there are Windows worker nodes. We also have a list of pods. Yeah, so now we are going to see all of the resources that are created in the My Grafana namespace. Here I have a Grafana daemon set and the Grafana service and the pods. We also have to set up some routes so we can access the Grafana dashboard. And I have also created a token which is used to securely access Prometheus. So yeah, this is the Prometheus route that has been created. This is going to be used in a Grafana dashboard in a minute. And yeah, this is just setting up all of the resources that we need. Yeah, so I am going to show you the kubelet summary stats API, and we are looking at the particular worker node that we have brought up. And this is just so that we verify that we have all of the metrics coming from Windows Exporter before we jump on to Grafana. So this is like a verification step. So here you will see all of the container metrics and yeah, all of the useful things like memory, network, maybe CPU, usage core. Yeah, that's the worker node. Yeah, now let's jump onto the Grafana dashboard. I'm going to add Prometheus as a data source because we have that set up to scrape the metrics. And yeah, as I mentioned, I'm just going to add the Prometheus URL that we saw in the routes when we queried that. And here we are setting up the authorization token, just the bearer token that I've created in the cluster. So this is just connecting us to the Prometheus API. And now I'm going to import a custom dashboard. This is a dashboard that is publicly available by Prometheus community. But this one is specific to Windows. There may be many more that are available. And yeah, so you would see something like this. You'd see the 2 worker nodes there and all of the things that you would want to monitor in one place. Yeah, and depending on your use case, you can add more things to this dashboard and yeah, utilize it. Now I'm just going to quickly show the Otel Collector config. The receiver and the exporter has been set to Prometheus and debug mode here, so we can see all of the metrics on the terminal directly. Yeah, and we have the Otel pod running, just looking at the logs here, and we have all of the metrics getting scraped. Yeah, now I'm going to pass it on to Ritika for debugging.
Thanks, Mansi. Well, we're quickly going to see the kubectl debug command that I talked about in action. Anyone who has debugged a Windows nodes knows the pain of having to set up SSH keys or RDP onto the node and look at files. You're going to see here how easy it is to get onto the host. Voila, we are already on the host over there using the kubectl debug command. Once you're on the host, you have full access to everything there. So you can look at the containerd logs, which usually sit in CVAR logs folder. We're going to show that. You can run networking tools, scripts. You can analyze data. You can kind of do a bunch of things, and we're going to walk over a few over here. Yeah, so that's me trying to download the host network systems collect logs, which is kind of like the suggested approach used to capture data packets, HNS trace, all of that things. And we're going to run it, and you see it does a bunch of runs. It captures your VFP policies, it collects traces, and you will see that all in that folder over there. And now we're going to also try and use the kubectl copy command, which makes it super easy to copy it from the node to your dev machine to analyze it using Wireshark or ETL analyzer, so on and so forth. So yeah, that's kind of majorly our demo. I think I do continue to do a run through of the container routes and stuff here, which we can see through. Yeah, so that's doing the kubectl copy command, which can help you get it on the developer machine. Yeah, there's all of the data from the node on your dev box. And those are the networking files. And there's a lot of information in there. If you're running into issues with your container failing to talk to the node, your container failing to communicate with another container, these are some files which are kind of like the starter pack to understand where your packets are getting dropped and so on and so forth. Yep. Those are the, I think we're looking at the container IP addresses that get generated. And that's the network routes file for Windows containers that come up. Well, that's about it. If you have any questions related to Windows containers debugging, building observability pipelines for them, feel free to reach out to Mansi and I. We're pretty active on the SIG Windows group in the Slack channel. And if you have further questions or discussion topics or features, feel free to stop by on Tuesdays to our SIG Windows meeting. We have it every Tuesday at 9:30 PST. And that's the QR code for feedback. Do share feedback on the session if you liked it. And if you want to hear something specifically the next time go around, we're open for questions. Thank you.
Thank you.